Hello, this is our presentation for statistics on heart failure data. I'm Benson Bird. This is Garion Cox. This is Joseph Finch. We are going to dive in right into it and talk about our data and where we got it.
So our data that we chose to use was from a research project on heart failure data and potential indicators of. And so the data was gathered from several locations throughout Hungary, the United States, Zurich, and another data set, the StatLog data set from the UCI machine learning repository.
We decided to focus on a narrow set of variables from the dataset. In particular, we studied these categorical variables: the patient's sex, the type of chest pain they had, which is classified as asymptomatic, atypical, anginal, non-anginal, and typical anginal. We also looked for the presence of heart disease in the dataset. It was a 1 for yes and 0 for no. And the presence of abnormal fasting blood sugar. Yes, if it's above 120 milligrams per deciliter, or no, otherwise. For numeric variables, we focus on the age of the patient, the resting blood pressure for the patient, and the max heart rate in beats per minute for the patient. Most of our data was already normal, so it was easier to work with. Although we did find that there was an outlier in the resting blood pressure, where someone had a value of 0, which is akin to a corpse and not what we expect.
Yeah, actually less than a corpse, so not good.
Yeah.
Okay, so here we have some graphs. We kind of wanted to start off by looking at the frequency of them attending the hospital. So as you can see, at the age, you have, somewhat normal, somewhat in the middle of, the most relevant is right after 50 years. You have maximum heart rate, which is, you can see that and read it. The resting heart rate versus the frequency and so forth. Yeah, they're pretty self-explanatory. Go ahead and go to the next one. We have 4 more. The chest pain types, as you can see, the ASY, which is one of the ones we've talked about, the asymptomatic one, is the most frequent out of those ones. You have the sex, so you can see male is more frequent, and then the fasting blood sugar, and the has heart disease and so forth. Those are pretty self-explanatory too.
Okay, so for our ANOVA tests, we wanted to test the difference between age, max heart rate, and fasting blood sugar, and the relationship between those. So our null hypothesis was that there wasn't any difference between them, and our hypothesis was...
And the difference in the means between...
Yeah, difference in the means. And so our hypothesis was that there was a difference. And as you can see from the graph, there are significant indicators. So we were able to reject the null because the data does provide significant evidence that there is a difference between the means of at least one of these 3 variables, and we would have to further test to find out what those are.
We were also interested to see if we could calculate the resting blood pressure based on the age and the max heart rate of patients who were in this data set. So we fit the data to a linear regression model, and we were able to get the equation you see on the screen now. Interesting to note that age positively affects the resting blood pressure, whereas the max heart rate negatively affects it.
The next thing we did was a confidence interval that we wanted to figure out to have some sort of prediction of a patient's max heart rate with a 90% interval confidence level, given that the age is 35. So what we were able to find is that the average max heart rate at age 35 was 155, 156, with a standard error of 2.8. And so what we're able to say now is that if you're at the age of 35, then we can kind of with 90% confidence say that you're beats per minute, your maximum heart rate is between 153 and 159 beats per minute. The last one we want to show you today is the chi-squared. So again, we have the null hypothesis where everything is totally normal, that there's no similarities, no association with one another, but we wanted to test that. We wanted to see if there's a significant association between chest pain types and the presence of heart disease. And as you can see, there's the 4 chest pain types, and our data that we collected that we want to show. We have the x-squared value and the p-value, and the p-value is very low, which means there is significant evidence that shows that there is an association with if you have a heart disease and what type of chest pain you feel. And that is all we wanted to present. Thank you for listening. This has been Us for Our Statistics.